Hello and welcome. My name is John Hawkes and I am the James Land Manager, and it's my great pleasure to welcome you to this online intelligence briefing today. Today, Sean O'Connor, who is Principal Research Analyst, Aerospace, Defence and Security, will present a session entitled S-300P and S-400, Russia's Strategic Defenders. The IHS Janes Intelligence Briefing Programme will consist of approximately 40 events during 2018 and is available to all customers of the Janes Intelligence Centre and module products, including the market's forecast products. Ladies and gentlemen, that concludes my introduction, but just before I do hand over to Sean, I'd like to highlight that the information used to compile today's presentation has been drawn from a variety of Janes content, but in particular Janes Military and Security Assessments Intelligence Centre. I'll now hand over to Sean for the development of the S-300P and the S-400 systems.
Good day, everyone. I'm Sean O'Connor, a Principal Research Analyst for the Aerospace, Defense and Security at Janes. And we're going to look today at the S-300P and S-400 strategic SAM systems. We'll look at their development, their system components and capabilities, and how to identify all the different systems in imagery based on the various combinations of equipment that we can see. To begin with, we'll start with the development history of the individual systems. So following the end of firing trials for the S-200 system, the VPK, or the Soviet Military Industrial Commission, solicited concepts for the next generation system to be developed. The desired characteristics were a multiple target engagement capability, which would have been the first for a Soviet SAM system, an anti-missile capability, extremely high mobility, and suitability for use across the Soviet military. The latter was already common to a degree, for example, with the Soviet Navy having adopted the PVO, or Soviet Air Defense Forces, S-125 SAM system as a naval system. MKB Strela, the design bureau which was the forerunner of the Almaz design bureau, proposed the S-300 series. Now, debate arose over whether one system could meet the requirements for all three intended service branches. And as we know, this was a relatively common thing throughout military development on both sides of the Iron Curtain in this time period. So testing of the S-300PS, which was the fully capable iteration of the system as conceived in 1969, began in 1978 at Seryshagin, and testing concluded in 1981, but service entry only occurred in 1983, following suitable infrastructure being developed. This was the fully mobile version of the system, and you can see it used a self-propelled launch vehicle based on the MAZ-543M chassis, the MAZ-7910, and the 5-minute emplacement time was validated during testing. Colonel General Anatoly Kufunin, the chair of the commission overseeing the testing of the S-300PS, was one of a group of individuals skeptical of the 5-minute deployment claim. So during one test, a battery was planned to drive to a launch position, set up, and fire at a target that had been launched over the test range. This didn't quite sit well with the general, as he was unsure of the logic behind using a pre-selected firing site to verify the system's deployment capability. And as it turns out, he ended up getting the demonstration that he desired, which validated the 5-minute deployment claim. As the system was moving towards the launch site, one of the vehicles in the convoy developed a mechanical issue, forcing the convoy to halt. And as the target drone had already been launched, rather than reschedule the test for a later period, they decided to go ahead and emplace the system on that location. So a geodesic tie-in was performed, everything was set up within 5 minutes, and the target was engaged as scheduled. And this validated that 5-minute deployment time. The S-300PT and S-300PS can also make use of 40V6 series mast assemblies to increase radar field of view. However, what this does is it is going to require a longer emplacement time because they have to remove the radar system, for example, from the mobile chassis it's mounted on for the S-300PS, and use a crane to attach it and then erect the 40V6 mast assembly. So depending upon the height of the mast involved, whether or not it uses an extension, it can take between 45 and 90 minutes to set up should they be using the mast assemblies. But without those, the 5-minute deployment time is going to be commonplace along all the variants that will be discussed that are not the S-300. Following this, work on the S-300PM began in 1983 using more advanced components and missiles that were being developed. Primary testing concluded in 1988, and the first batteries appeared in service in the Moscow SAM ring in 1989. Given the new capability of the missile systems, the system was now classified as a long-range SAM as it had a much greater engagement envelope when compared to the S-300PS. This was accomplished by using more efficient rocket propellant, which removed the need to develop a larger missile, which would possibly have necessitated developing a newer and larger, more complicated tail design. Testing continued on various enhancements, with particular attention being paid to anti-missile capabilities following Russian analysis of Patriot missile intercepts in the 1991 Gulf War. Continued upgrade programs were Favorit and Favorit S, the former being an export program and the latter applied to Moscow area S-300P and batteries by 2012. S-400 development began in 1985. This was to be classified as a 400-kilometer long-range SAM system capable of replacing the S-200. Now, at this time, there was also an S-350 version under consideration as an S-300P series replacement. And by 1988, both of these program goals were consolidated as the S-400, with the S-350 designator later appearing as another S-300PS replacement program, completely different from the original iteration. S-400 trials began at Kapustin Yar in 1993 using the 48N6D missile system employed by the S-300PM. And trials proceeded relatively slowly due to the economic issues following the breakup of the Soviet. These are the engagement radars that are used by the system. The 5N63 system is mounted on a trailer and towed and then emplaced for the use by the S-300PT. All the other systems are mounted on mobile chassis. The versions for the later S-300P variants are mounted on a MAZ 7910, and the version for the S-400 is mounted on an MZKT 7930. All of these systems can be mounted to top 40 V6 series mast assemblies. The radar is an optical space-fed, passive electronically scanned array. It has very low side lobes due to the use of 4 side lobe canceling antennas which surround the engagement radar array, and each of these 4 circular antennas can be used to basically sample unwanted energy coming in from enemy jammers so that it can then be fed into the radar receiver channel out of phase with the jamming signal present in the actual received signal path, and this reduces the effects of the jamming. This also creates a null in the antenna coverage towards the jammer, but the use of these 4 side lobe canceller antennas enables the system to cope with up to 4 jamming systems simultaneously. Also, the use of a very narrow pencil beam main lobe makes the system harder to detect. These are some of the missile capabilities for the various versions, starting with the original 5V55K command-guided system for the S-300PT. At a range capability of about 47 kilometers and an altitude capability of about 25,000 meters. As you can see, as newer versions of the missiles were introduced, the range capability and the altitude capability increased, as well as the warhead size in some cases. Most of the original warheads were high explosive fragmentation systems. However, the latest 2 versions, the 48N6D and the 48N6DM, use a 180 kilogram directional warhead. The 40N6 system is not listed as it's not yet assessed to be operational, and the 9M96 series, although it's been offered as part of the S-300 PMU2 Favorit export model, it's not listed as there's no country who's actually procured that option. And in Russian service, it's not employed by the S-400 batteries. Instead, it's going to form part of that forthcoming S-300. And if you look at these individual launchers, you can see how the front end is actually split apart to form those 2 stabilizer arms. And then when the missile tubes actually erect, they're going to erect forward into that space, as opposed to all the other versions of the system which actually erect at the rear of the launch vehicle. The reason they chose this arrangement is not really known, but again, this is the reason why this version of the system is completely incapable of meeting that 5-minute setup time. And it also makes it relatively simple to identify this version in imagery as well, because it's got a very unique signature. One of the impacts on the export market related to the S-300 or S-400 is that as the newer systems become available and enter service with the Russian military, they're then typically offered for the export market. The S-400 has been in service for a while, and as the newer system, the S-500 is currently undergoing testing down at Ashalok, the S-400 is now starting to be delivered and ordered by other clients. So again, China is that first confirmed customer, and they are currently in the process of taking delivery of their first S-400 batteries. And again, we also expect the S-350 to enter the export market once it eventually enters operational service in Russia. The reason for that is because it's already been marketed for export, and it hasn't even entered service yet. Replacement of older S-300PS and PM batteries with newer systems also potentially releases the older systems for export. We've already seen cases such as Kazakhstan, Belarus, Armenia, where they've actually taken delivery of refurbished former Russian or Soviet stocks of these systems. And that basically provides them with a much more advanced air defense capability at a much cheaper cost. Modernization programs such as Favorit S could also be attractive to FSU users who are using the S-300PS system. It would allow them to basically replace the engagement radar with the more capable 30N6 variant, and then they could use the much longer range 48N6 series missile system.
This does conclude our seminar, so thank you for joining us today for this event. We look forward to welcoming you to our future online briefings. Our next online briefing is going to be about Gulf defence markets, and that's being held on Wednesday, the 20th of September at 1500 UK at 10 o'clock EST.